Hey everyone, Nitesh this side. Hope you're doing well. So let's start with the question. So the question is the k weakest row in a matrix. So you are given a m cross n binary matrix of ones, basically one representing soldier and zero representing civilians. So the soldier are positioned in front of the civilians. Okay, so soldier will be like in the front of civilians. That is all the one will appear to the left of all the zeros in the each row. Okay, so if you can see in this example, so till this point soldier are standing, and after this all the civilians are standing. Okay, so a row is a weaker than a row j if one of the following is true. Okay, so the number of soldier in row I is less than the number of soldier in row j. Okay, this is the one condition. If the soldier is less in row I then the j, then it's a one condition. And also both rows, if both rows have the same number of soldier, then whoever comes, like whichever rows come first, it will be the weakest row. Okay, so what you have to do, you have to return the indices of kth weakest row in the matrix order from weakest to strongest. Okay, so you are given a matrix of m cross n in which it's a binary matrix, and one represent, you can say, a soldier, and zero represent a civilian, and all soldier will stand before the civilian. So if you can see at this point, till there all the soldier are standing and then the civilian. So what you have to do, you have to calculate the kth weakest kth weakest row. And how can you calculate the weakest row? So the condition is, first the the soldier at the particular row should be less than the other row. And the second condition, if both have the same, so let's say for this case both have this and this, both have same soldier, then you have to identify on the basis of index. So as you can see, this index will come first, so we will take this row. Okay, so let's understand with an example. Okay, so let's take this example. So first of all, calculate the count of each. So let's say this is row 0, so for this we have 2. For 1 we have, you can say, 1 2 3 4 soldiers. For second row we have only 1. Okay, now for this we have 2, and for this we have 1 2 3 4 5. Okay, so for this 5. So what you have to do, you have to return the weakest rows from this matrix. Okay, so let's take, you can say, what you have to do, you have to return the kth weakest. So if we sort them, so this is the smallest first one. Okay, so we can take this, so we will say like answer array. So we'll take this row, so we'll take 2. Then let's see the smallest one. The smallest one is this also and this also. So if the soldier are same, what we will do, we will check on the basis of index whoever is smaller. So we can see this is smaller, so we will take this index, then 0, and then we have a 3, this 3 index. Okay, after this we will not take it any other because k is equal to 3 only. So this is the final output. Okay, let's take this example also. So let's calculate for this row. So for this we have 1 soldier. For the first row we have 1 2 3 4. For this we have only 1, and for this we have only 1. Okay, so we can see the smallest are these. Now how we will identify? So we will take answer output. So first we will take this because this is the smallest index, so we will take 0. And after this, these two are also same, so we'll take the smallest one, so we'll take the smallest index. Okay, so for the weakest, okay, how you have to do, you have to first calculate the lesser soldier, and if both the soldiers are same, you have to take the smallest index row. Okay, whoever comes first, basically. Okay, I hope you got the question and you also got how we can approach this. So it's simple. What we can do is, we can, at every time we can count the first step is to, at every row, first step is to count the soldier, and then the second step is to basically you will store in a list, or let's say we will store in a list. all the count of the soldier and their indexes respectively. Okay, so these are the two steps to solve this question. So let's see how we will solve this. So what we can do first, solve this approach. Okay, like we have to store in a list. Okay, why we are storing in a list? Because these, you can say this all we can store in a list. After this we will sort it and we can find out the kth element. Okay, now if you sort this array and you will basically take MLogN, any sorting algorithm, and what you are also doing, you are also taking an extra space also. So what we can do is we can think of a, you can say, a data structure which can give us the only the smaller element, whoever like the present in it. Okay, so what we can use I guess a heap type of. So what we can do, we can use a min heap. Okay, so if we use min heap and insert all the elements, so let's say we'll insert this, you can say this is a min heap. So we'll insert this 0 2, like this is the representing 0 in the index, and this 2, and after that we insert 1 4, then we insert 2 1, then we insert 3 2, then we insert 4 5. Okay, so at every time what we can do is we can take the smallest element, like min heap always give us the smallest element and we'll take it. So like at this point this will give me this, you can say this is a one one soldier, so this is the smallest, then it can give me this. Out of this, like there can be a comparator which compare it, but what we are also doing is we are taking a extra space of, you can say, whole order of n. Okay, can we solve, like can we reduce this? Because what we are doing is we are inserting all the element into a heap, but do we really need all the element? Can't we just take only, like keep only kth element? Why we need all the element only? Okay, so let's say we'll take a min heap and we'll insert only kth element. Okay, so let's say this element is come, we'll insert it, and whenever our size is greater than k, we'll pop it. Okay, so let's say this is inserted, then the second element is come, this we will only insert it. After this, this also come, like our k is 3, so right now no any condition greater than size, so we'll insert 2 1 also. Now this come 3 2. Okay, so we'll insert 3 2, and now we will pop out the maximum element because we don't need it. But let's say, so this is a 3 2, and let's say either we need this or not. Okay, so now our size is 4 and which is greater than our k, so we need to pop the element. But if you pop in the min heap, so what it will do, it will remove the smallest element, but we don't have to remove the smallest element. In this case the bigger element is only this, because this we don't need this 1 4, we can pop it. But if we pop this out, how can we pop out? Like in the min heap the smallest element is this, but as you can see we need to pop this, but we are getting this element to pop. So what we will do, instead of min heap we'll take a max heap. Okay, so let's do the same, we'll take a max heap and we'll insert. Okay, so like let me just write down all the rows. So this is 0 2 1 4, then we have 2 1 3, like this is representing row and this representing soldier, 3 2, and this is 4 5. Okay, so what we will do, we will take this and we'll insert it 0 2, then we'll take this and we'll insert it 1 4, then we'll take this and we'll insert it 2 1, then we came a 3 2, we'll insert it, and now our size is greater than key, so we'll need to pop it. Okay, so which is the maximum element? So as you can see this is having the maximum soldier, so we need to pop this, and max heap only give the maximum element, so this will pop this element. So now our heap only having 3 elements, this and this. Okay, so now we encounter a new you can say element, so we'll insert it, so this become 4 5. So now again our size is greater than k, so what we will do, we will pop the element, and now if you compare whichever is maximum, so this is maximum, like this heap implementation, it's automatically take the maximum element at the top. So it will pop this element, and now we only have this 3 elements. So this, and we can easily just print this out. So this index 0, then like you can take this 2 index, then you can take this 0th index, and you can take this 3. Basically it will give you in the reverse order. So first this will pop out, 3 will come, then this 0, 2 will pop out, and then this 2, 1. So we'll get in a reverse order, but we get the sorted, and we only take a, you can say, a order of k space complexity. So we have reduced from order of n to order of k. Okay, so we have done with our step 2. Now let's see for the first step. Okay, can we optimize this? So let's see. Okay, so we have solved our second condition. So this is our first condition, this is second. So we have optimized our second condition by using a max step. Let's see, can we approach, like, can we optimize this counting the soldier? So what we are doing is we are taking, let's say this is the array at every time 1 1 0, 0. So what we will do, we will count the 1 in it. So we will come at here, and every time we will take a counter and will increment it. Okay, so what you can say, this is taking a order of n approach, our time complexity. You can also say we can optimize it by, like, whenever we encounter a 0, we will just break it, because in the question it's already mentioned, like, all ones will always stand before all 0. So this is also, you can say, order of n if you stop at here also, but there is a condition. Let's say for this array you will go to the end of the array. Okay, so can we optimize this? Okay, so what you can think is, this is a sorted array. Okay, like sorted it, like it's in the descending order, if you can say, and we yesterday discussed like a binary search we can use here. Okay, so sorting for binary search, it's not necessary that it's always in the sort ascending order, it can be in a descending order also. So what we can do is we will apply a binary search over here. Okay, so we will approach binary search. How we will approach? So let's see, let's take this example only. So this is 1 1 0 0 0. So this is our index 0 1 2 3 4. If you don't know about binary search, you can check my previous video where I've discussed what is binary search. So what we will do, we will take a start pointer and we'll take a end pointer. So in binary search, what we are generally do, we will take a middle element. Okay, so we'll calculate the mid. So at this case, 0 plus 4 divided by 2, so this is 2. So our mid is come at here. Okay, so whenever we encounter, you can say, if our array of mid is equal to 1, we'll do something. If it is 0, what you have to do, you don't have to go in the right part, you have to just reduce your end. So end will only search in the, so if this is, you can say, is 0, so what you will do, you will decrement your end. But if there is 1 at your middle, like whenever you are standing at this point, so if this is 1, what you will do, you will search in the right part only. So this, like, we just optimize a binary search, we are not returning from here only. So what we will do, we will update our start, so this will become mid plus 1. So as you can see, this is 0, so we'll lies in this condition, so we'll update our end, and end now point to this, so end will come here. Now again we will calculate the mid. So mid is 0 plus 1 divided by 2, which is 0. Okay, so mid is come at here. Okay, so first step is to check whether this is equal to 1. Yes, this is equal to 1. So what you will do, you will update your start. So start will now come at here. Okay, now again you calculate the mid. So this is 1 plus 1 divided by 2, which is 1. So your mid is also at here, and you will check whether this is equal to 1. So you will again increment your start. So start will come at here, and now, like, there is a condition for binary search, so while start is only less than end, you will just loop this over. Otherwise you just return the, you can say, return a start pointer. So as you can see, this index will represent as equal to 2, so we'll return 2 from here. And as you also can see, we have only 2 1. Okay, you can try with your own also. So let's write the code for this. Okay, so what we need a priority, you can say a min heap. In Java we can implement it through priority queue, and it's will be a type of, you can say, a array. Why we are taking a type of array? Because we need to store two things. One is soldier, and the second thing is, you can say, which row is representing that soldier. So we'll take a max heap. So we'll use a max heap, and let's, it will be a priority queue of, and let's use a comparator also, because we need to compare the, let's write it down like this. Let's take a override public int compare int 1v. Okay, 0th index will represent the row and 1 will represent the, or let's do it like this, return array of, so we'll take the 0th as soldier, b of 0 minus a of 0, and if both the soldiers are same, what we will do, if array of 0 is equal to b of 0, we'll sort them on the basis of row. So this will be, b will come first. So we have converted this in a maximum heap. Okay, now what we will do, we will loop over our matrix. I plus plus. What you will do, you will just do q dot add, it's not a queue, it's a max heap. Max heap dot add new int. So first representing the soldier, so we will get it from binary search, and we'll pass the array, so matrix of I, and we'll give the corresponding row to its. Okay, and after this we need to do one more thing. If max heap dot size is greater than k, what you have to do, you have to do max heap dot pop or remove. Okay, so you have created your max heap, and we have to return it in an array. So let's take a answer variable, and let's take a k size. So while k greater than 0, we'll do answer of minus k. We'll take max heap dot remove, and we'll take the, we'll only give the, you can say, the row. So this, after this we just return the answer. So we have completed, okay, so binary search is remaining for the count. So let's take binary search. We'll take a array. First step is to take the start and end variable. Okay, and while your start is less than end, what you have to do, you have to calculate first mid. So we'll calculate by this way, and if array of mid is equal to 1, we'll do something, else we do something. If it is equal to 1, so what we will do, we'll update our start. So start will become mid plus 1, else end equal to mid minus 1, and after that we just return our start. Okay, this looks good to me. Let's run the code. Let's see. As you can see, this is giving the correct output. Let's submit it. Okay, our code is also submitted. And the time complex, calculate the time complexity. So we are taking a priority queue. So, and we are doing a loop over of a matrix. So this is, you can say, order of m for the iteration of a loop. And the second thing what we are doing is we are inserting the element. So this is for order of m for this, and what we are doing is we are doing a binary search over a n length of an array. So it's a order of log n, and we are also inserting into a max heap. So max heap addition will take order of log of k, because we are only storing the kth element in the max heap. So it's a, you can say, a order of n log k plus order of n into sorry, it's a order of m into log k and plus order of m into order of log n also. So on an average, it's a order of n log n, and space we are using a parity queue. So for this, we are using a order of k size. Hope you like it. Thank you for watching my video, and do join the Telegram group if you have any doubt and any concern. Thank you.